So, good morning to all of you. Today, we will concentrate on shift registers. So, how a register can be shifted, its a value, and what are the promises you are supposed to use. So, here we are trying to utilize or we are trying to discuss only unidirectional shift register. Unidirectional in the sense probably towards left or towards right. So today we would like to discuss only towards right. So we would like to discuss only this kind of shift register. Already you have operated in C. There are shift operations, left shift and right shift. Two different types of operations are there in C programming. So you know very well. So that for example, integer shift operations will be gets operated on only integers. Integer a will be equal to some 5, for example. So then followed by, so let us consider b will be also declared by me. So b is equal to a right shift of 1. If I would operate something like this, what exactly the operation will be took place for this particular kind of shift operation here? If you want to operate something like this, what exactly it is being operated here? What exactly operated here in the sense, number of bits which have been there with you will be shifted towards right side. So normally, this is the actual integer which is being occupied. 16 bits of so space is being gets occupied. So let me take only last 4 bits because to store a we require only last 4 bits. So in the actual 5, how it could be get stored here in the sense, this is 1, this is 0, and this is 1, and remaining everything will be 0, 0, 0, 0, 0, and so on and so forth. Everything will be 0. So like this. So let us consider this is a is equal to a will be seems like this. Then b will be seems b will be equal to same kind of occupation could be also there because it is also an integer. It's also as like as a. It's also an integer. So here also we would like to take something like only 4 bits and remaining everything will be of course zeros only. When you will be consider this particular operation, when we will be consider right shift, so this bit will be discarded. This bit will be out of the range of so your variable. So this will be goes off, and this bit will be stored here. This bit will be stored here. This will be stored here, and so on and so forth. This will be stored here. So if you move in such a fashion, 1 will be goes off, 0 will be at this particular LSB. So 1 will be placed LSB. So just before this is 0, and of course everything will be gets 0 only. So all these things are 16. I mean 2 has been gets over. So 14 zeros will be loaded. So 2 power 0. This is 2 power 0, 2 power 1, and 2 power 2. So 2 power 0 is 1. So 2 power 2 equal to 4. 4 plus 1 equal to 5. Similar fashion here you have to take, so 2 power 0, 2 power 1. So this value equal to 5, and whereas this value equal to 2. As and when you have to operate right shift operation, the value of your integer will be gets reduced by half, exactly half here. So that is why it would be considered as a right shift operation. And then when people will ask you one question, that how could you divide the, I mean, how could you make 50% of a given integer without using any arithmetic operations, in the sense you may be operate so by whatever the integer, as like as our example which we have taken just before, a right shift of 1. What does it means? So a value equal to 5, and the right shift of 1 in the sense one value could be goes off, and you will get actually it is 2.5 for integers. Decimal places could not be there, so that is why it is 2. So we would like to discuss only this particular point today, And of course, if you want to operate in terms of left shift, you may be, so reverse the circuit, then it will becomes into left shift operation. So these are the two operations, are left shift or right shift operations, which are available in any language. So how these could be gets operated, how the things will be. So as far as language is concerned, every variable, every integer variable be occupies 16 bits. So, but we are discussing only 4 bits because for our convenience point of view, we would like to discuss only 4 bit. So let us see. So a register is capable of shifting binary information towards either direction. So either probably right side or it is left side. If it is directed towards right side, that is called as a right shift. And if it is have a capability to move left side, then it is called as left shift. So right shift or left shift. We are supposed to discuss about only right shift, not towards left shift here, unidirectional shifting operation. Okay. And what exactly it is going to do here in the sense, how many number of bits are there with you, those many number of flip-flops are going to be cascaded in the sense they will be arranged one after another, and you have to operate the shift operation. Okay, in this direction, the data will be so shifted towards left or right, of course. So please remember, our discussion will be only right shift. Please remember this one. Okay. So, however, logic, I mean, a chain of flip-flops are going to be so attached in cascade mode. Okay, and followed by flip-flops are receiving the common clock. I mean, battery, the power, electricity will be received commonly, and as and when clock will be just simply equal to 1, then shift operation will be took place. If clock will be equal to 0, shift operation could not be took place. So that is the basic difference here. Okay, let us see how the shift operations will be. So let me eliminate, I mean, clear off everything here. Let me clear off everything here, then you could understand. So for this shifting operation, we would like to consider D flip-flops. Okay, so 4-bit shifting is going to take place here, so that I'd like to consider 4 D flip-flops here. And clock will be common, as I said just before. So it has been received common clock. It has been taken, common clock pulse will be taken, so that the common clock will be taken into consideration. It is clock pulse, and the input will be seems like this. So that is so shift input, and this is shift output here. Okay, so let us consider initially, if you have 4 bits of information is there with you, initially 1, 0, 1, 1. If this is the data where exactly you have with you, then clock pulse will be equal to initially it equal to 0. For example, it will be equal to 0. Then what would be happen? So if this shift is not being took place here. As and when clock will be equal to, so this clock will be, normally clock will be happen something like this. This is the way of building this particular clock in terms of digital systems. So here, if you consider, if clock will be, just before I told you, so A will be equal to some value, so B will be equal to, B will be equal to A right shift of 1. I have taken 1 here. What do you mean by 1 here? Second parameter will be took place something like this. It will be clock pulse will be equal to 1 up to 1 clock pulse. This is called as 1 clock pulse here. Okay, 1 lower and one upper. So this will be called as 1 clock pulse. Up to this amount of time, clock pulse will be becomes 1, so that 1 shift operation will be gets happen. So this value could be goes off. This value could be goes off. This value will be placed here, and this value will be placed here, and this value will be placed here, so that the output will be seems like this. So here it is. If any empty vacant spaces will be there, fill with zeros. Okay, here it is 1, and here it is 0, and here it is 1, and here it is vacant. Actually, no data is available here, so that it would be considered as 0. So now you are expected to shift for only one time, so that for 1 clock pulse, the CP will be equal to 0. So as and when CP will be equal to 0, immediately shift operation will be took place. After 1 unit of time, CP will be becomes 1, 0 again. CP will not will not be activated mode. If CP will not be, I mean, clock is not there with the day flip-flops, obviously you could not do, or you could not operate any flip-flop here. So that initially 1011 will be there, then this pattern will be seems like this initially. So 1011. After one clock pulse will be took place, obviously, so 0, 1, 0, 1, something like this. It could be happen something like this. In this way, so the shift operation is being happening here. So based on the second parameter or second operand, what we have given at the shift operation, so that could be took place here. If you are supposed to give, instead of this one, for example, this is the new operation which we have to operate. A will be equal to 10, and B will, let me eliminate this one, and I'll write one more time, then you could understand very clearly. Let me eliminate this one here for time being. So let me consider something like this. A will be equal to 10, and B will be equal to, so B will be equal to A. So right shift of 2. What exactly it does means, A right shift of 2 in the sense it may be taken, so from here to this time, up to this particular amount of time. This is 1 clock pulse, and this is a second clock pulse. Okay, what exactly will be happen here? For the first shifting, initial value will be, let me write initial value in blue color. So initial value A equal to 10 in the sense, so 1, 0, 1, 0. This is the initial value. For the first time shifting, let me take the color as red. This red will be first shift operation. First shift operation. So as and when first shift operation will be took place, this will be vanished, and this value could be comes here, and this value could be placed here. This will be goes off. It could not be there, and this value could be comes here, so that this is 0, and this value could be comes here, so that this will be 1. So empty spaces will be there, so that place 0 here. This is first time. And if it is the second time, for example, it could be take, okay, let me take this color. So second time, because now CP will be activated for, so 2 units of time at this moment. First unit of time is gets over, and second unit of time at the second level, let me write inside the this one. So second unit of time, so this value will be again goes off here. It could not be available. This value can be placed here, that is 0. And this value can be placed here, that is 1. And this value can be placed here, that is 0. No data is available, so fill with zeros. So finally, after doing this one, so initially A value in terms of binary will be equal to 1, 0, 1, 0. B value after doing 2 shift operations, it could be 0, 0, 1, 0, 0, 0, 1, 0. So here it is 10 actual decimal value. Here it is 2. Okay, so twice it could be done. It could be done what? 2 in the sense. What is the second operand which could be taken by the shift operation is how much amount of time the clock will be provided to the shift register. That could be decided by second one. Okay, second operand here. If it is 2 units of 2 clock pulses will be supplied. If it is 3 clock pulses will be supplied. Something like that. So 3 times the shift operation will be gets happened. In this way, you have to shift the specific operations here. But sometimes the same thing will be happen in terms of logical operations. So serial shift operations will be took place here. What do you mean by serial shift operation? Let us consider. So I'd like to define something here. Serial shift in the sense, this is 4-bit shift operation. I mean 4-bit shift register. It's also be 4-bit shift register, for example. If a serial shift operation will be took place, how this could be seen? So like this. Whatever the output, when shifting is being done, whatever the output, that output will be connected to, so shift register A back, and the same output will be sent to shift register B also. Okay. So now you can see, I'll give you some example, then you will understand very easily when compared to this one. So if you consider, so this particular clock will be taken for these 2 shift registers, something like this. always clock will be always on if your power will be connected. So this signal will be sent continuously. It could be gets on only continuously. But here you could see clock will be drawn from AND gate. Clock will be drawn from AND gate. So power will be continuously available. But if you consider your electrical switch, so through your outside, I mean from the pole to your home, continuously power will be there. But fan will not be rotate until unless you have to switch on that particular switch here. You may be on that switch, then only power. So fan will be rotated, then you could enjoy the air. Okay, something like that only. So here also, so the thing will be as and when shift control will be activated, then only clock will be generated and the clock will be supplied to register A and register B. If a shift control, it is always one. Clock is always one. For example, shift control will be 0. So output of this AND gate will be 1 and 0 will be, here it is 0, here also 0. Both will be 0. So therefore, so register A and register B could not be work anymore. Okay. So for one clock pulse, so only one clock pulse, shift control will be 1. So here it is 1 for one clock pulse. Here also equal to 1 for one clock pulse. So one shift operation will be happening. Let me illustrate you by taking some other diagrams. So here it is, this is the clock actually. This is the clock actually. And this is shift control. Let me write SC, shift control. So shift control is happen. So look at this. This is one clock up to this clock pulse. And this is second clock pulse. And this is third clock pulse. And this is fourth clock pulse. So up to 4 clock pulses, shift control is gets open. Open in the sense gets equal to 1. So 4 times this shift control will be shift its value continuously. After 4th unit of time, so shift control will be become 0. Look at this. This is become 0, so that your output will be get 0. So clock will be 0 for both the shift register A and shift register B. So during these two, if you consider these two, so how the data will be, how the clock will be, CLK will be, this is CLK, this is CLK. So let us consider, let me take some other color, then it is very easy to understand. So from here to here, no data is there, so CLK will be 0. From here to here, no data is there, so there is no data, here it is 0, here it is 0, so that it is also 0. From here to here, no data, I mean no, so SC, so shift control is 0, so that CL also 0. Observe this one, try to observe at this particular situation, scenario, from this place to up to this particular place, shift control is becomes 1. So here it is 1, here it is 1, here it is 1, here also equal to 1. So therefore, so here 1 will be there, here 1 will be there, here also 1 will be there, and here also 1 will be there. Right away from this place to entire other timing diagram, there is no shift control, obviously clock also 0. So let me consider this is T1. So first unit of time will be T1, second unit of time will be T2, third unit of time will be T3, and so on, T4. So it does have some value. For example, 1011, it does have 0110. For example, these values. At T1, what exactly been happen here? At T1, 1 bit will be forwarded to shift register B and also so back to shift register A. Look at this. Initial values are 1011. This is A, shift register A, and shift register B will be 0110. Now at T1, at this particular place, so what actually been happen? This bit will be moved to B, and this bit will be vanished. This bit will be no more. This bit will not available here, and this bit will be moved to this area 1, and this is moved towards, and this is moved towards, and this bit will be vanished. It could not be stored anywhere else. Similarly, this bit will be moved here, so that this bit will be comes here, and 0 will be comes to this place, and 1 will be comes to this place. Because of this feedback mechanism, because of this feedback, so this bit, whatever the bit you have moved to B, that will be placed back to your, so A again. This is at T1. This is at T1. At T2, again one more shifting is being happening. So this bit will be goes off. This bit will be goes off. So that what exactly you have? 1 will be there, 0 will be there, and this 1 will be comes to this place, and this 1 will be comes to this place, and this 0 will be comes to this place. 1, again 1. So this one will be placed back here. So 111 0. Okay, 111 0. Now at T2, T3, at T3, so again this bit will be goes off. So therefore 0 will be moves here, 1 will be moves here, 1 will be moves here. This 0 will become this place, and this one will be come to here, this one will be come to here, this one will be come to here. Because of this feedback, 0 will be goes to at this place. Okay. So at T4, again, I have one more example with me. So I'll show you at the end of this one. So this 0 will be goes off here. It could not be stored anywhere else. 1 will be moved to this place. 1 will be moved to this place. 0 will become here. This one will become this place. And 1, and this one we see here. This one will be here. This 0 will be here. And this one, because of feedback, this one will be goes at this place. Okay, this is the final output as and when you have to operate with SC as 4. So here we have taken 4. Where exactly this could be used here in the sense, this could be used in logics as and when you have to operate some kind of logics. Let me give you these logics by tomorrow. Where exactly this could be operated in your programming languages, I'll give you. More probable operations will be for Python. So for Python, these operations will be could happen here. Okay. Look at this. These are the specifications where exactly I have taken some example in the previous explanation. So this is one more example. Initial values will be these. 10 10 11 is initial value for shift register A. Shift register B 0010. So look at this. This 0 will be vanished, and 1 will be placed here. This 0 will be placed here. This 0 will be placed here. Shift register value 1 has been placed here, and this one will be moved here, this 0 will be moved here, this one will be moved here. Because, so here look at this, because of this particular feedback, so this one will be, same one will be placed, this one will be placed at this direction. Okay, so that your value could be seen in such a way. After T2, second unit of time, this one will be goes off, 0 will be placed here, 1 will be placed here, this one, and whatever the previous value of shift register 1 has been placed here, and this 0 will be moved, and 1 will be, and this 1 will be, because of, so the, what you call, backing, I mean feedback, this 0, this one will be placed here. So in this way, your operations are going to be happen. So this is called as serial shifting. Serial shifting. Okay. So in more and more programming languages, we maybe gets operated something like this, only shift operation towards right. Otherwise, some B will be equal to, some C will be equal to. So A shift operation left, so will be 1, will be gets operated. Only these two are there. Actually, in programming languages, this operation could be happen with only Python. Let me recall you where exactly this could be gets happen. Of course, Python is not there with you. I'm thinking that you are second year. Sorry, you are first year. So when you will be there in second year, I'd like to inform where exactly this particular point will be. Okay. So this is what about the complete information regarding to shift operation. Okay, shift operation will be like this. So look at this. This is the shift register, which is very useful to you. So which could be so operated continuously in our languages, in our in our languages here. So here, so operations will be gets happen in based on the clock pulse. If clock pulse will be equal to 1, only one time shifting will be happen. If clock pulse will be equal to 2, twice shifting will be happen. Clock pulse will be, clock pulse, how this clock pulse will be activated here in the sense, as and when you have to operate, some B will be equal to some value of A, right shift of 3. So now clock pulse will be activated up to 3 units of time. Okay, if it is, for example, it is 5 in the sense, 5 units of time, the clock pulse will be gets activated. For example, it could be only 1, so single unit of time, so the clock pulse will be gets activated. Whatever the parameter you have given at right side, that must not be equal to 0. Okay, that must not be equal to, so less than or equal to 0. Negative also not to be taken. Okay, so in this way, shift registers are supposed to be worked out here. This is the premises. If you have any questions, you please ping me. So I will be available for you. So at any moment of time, so I shall be there with you. Okay, up to 5:30, I shall be available. So thank you for now.